Okay, let me start. Annalie, you're trying to say something?
Professor,
Sunny, you're trying to say?
I have just
Can you know the presentation order? I don't have an
for
order. I think we just go by the group order. I think there should be 8 groups. So 1, 2, 3, 4. That's the order I was planning to do. That's what I said yesterday. If you guys want to have a different order, I am fine with it. But yeah, I don't have any particular order per se. Okay. Okay. Let me start and try to finish because I have this bit to kind of complete before because that's something I thought I will do. So, any questions from yesterday? Any questions from yesterday? Okay, if there are no questions from yesterday, let's start and let's kind of listen to this. So, in effect, what I have is the last. I mean, before I just go into swaps, and actually the swaptions will have to be done after that. But before I go into swaps, so in as much as we use the Black-Scholes formula for pricing under pricing options on European options on equity, on dividend, on assets which pay dividends, non-dividends, obviously, and to some extent currency, because you can kind of treat currency as a dividend paying option. We did not use that as a means to price or as a means to kind of look at options on interest rates or interest rate products. However, remember in the very first day, or not first, the first day when I was talking about derivatives, I had also highlighted that that interest rates are also can also be treated as an underlying. Interest rates can also be treated as an underlying in that context, and interest rates can kind of be used. Remember, we are highlighted them as notional assets. So what Black's formula does, and I'll go through the formula in a second. What Black's formula does is kind of prices it for an interest rate. The only difference or only complication, additional complication that comes in is interest rate changes in the market can either be modeled directly by taking interest rate as the underlying or using bonds. Using bonds also, you could potentially run that process. Because remember, what is a bond price dependent on? A bond price is going to be dependent on, and I'll come to this slide in a minute. A bond price is dependent on the face value of the bond, the coupon on the bond, the time to maturity on the bond, and the discount rate on the bond. Right? These 4 terms. Now, of these 4 terms, the face value of the principal of the bond is constant. The coupon rate in a fixed coupon bond is constant. And the time to maturity changes, but changes deterministically. What do I mean by that? What I mean by that is the time to maturity today is, 5 years. Tomorrow it will necessarily be 4 years to 64 days, and then 4 years to 63 days, and so on and so forth. It cannot do any random changes. And hence, it is easy for us to kind of look at, I mean, it is not that difficult to kind of account for that change, right? So so that's deterministic change. So the only term that can change randomly in the whole bond price equation is the value of the bond. Is the discount rate. And because the discount rate can move randomly, the value of the bond can also move randomly. So the whole argument is that the value of the bond can move randomly because the discount rate moves randomly. So hence, the random movement of the bond price and is kind of directly linked or is kind of in perfect synchronization, in a perfectly matched with the random movement in the underlying interest rate. The only difference is we know that bond prices and interest rates are inverse to each other. What does it mean? Which means that as the interest rates rise, bond prices go down. If interest rates go down, bond prices go up. So that is the only difference, the only point that has to be accounted for. But bonds and interest rates can interchange each other as an underlying asset. Now, while that part is true, there's one small thing that comes in that one has to be careful about, which is, remember, when does the settlement happen? So if I want to physically hand over a bond to you, settlement can happen immediately at the point when the bond is being handed over. So therefore, there is an immediate settlement at the point when the bond is handed over. However, when it's an interest rate, what happens is that it's the interest rate part of it will happen, or the payout on the interest rate will happen only on the end of the interest rate period. So basically, if I tell you right now, you have a benefit of, let's say, 3%. When do you get the benefit? You don't get the benefit today. You get the benefit at the end of the borrowing of the lending period. Because if you borrow or lend for that period, you will get an interest rate which is 3% better, under which you're going to be better off by 3% with respect to the market condition. So with respect to the market, you are going to be better off by 3%. That will happen only if you are that will happen only at the end of the borrowing period. So therefore, the benefit that you will earn from a coupon, from a bond, the time point at which you will earn the benefit from an interest rate, what would otherwise be called as a naked interest rate position, is much later than what you would earn from on the expiry of the derivative. So to that extent, you have to be careful about when do you earn the benefit. And again, let me repeat, for the case of a naked interest rate, or for the case of just a plain interest rate, the benefit does not come to you at the expiry of the bond of the derivative, but the benefit comes to you at the expiry of the interest rate contract. Now, the interest rate contract starts only after the expiry of the derivative contract, which basically means that in a naked interest rate contract position, the benefit comes to you at a point later than the expiry of the derivative contract. If it was a bond contract, the benefit would come to you immediately on the expiry because the bond can physically be handed over. While the bond helps you do the same thing or track the same thing in terms of interest rates and in terms of the movement in interest rates and all of that, the bond can kind of be handed over immediately on expiry, and hence the bond contract kind of and then in that context, the bond has an immediate payoff on maturity of the derivative contract, not the interest rate product by itself. Okay. So that is one thing that we actually have to keep in mind, and this is arising from the fact that both are possible, both are feasible, and hence, since both are feasible, that is when both are feasible is underlying, so we'll have to account for it differently and accordingly. And now, if you look at what I have written out there, you can see this line out there where I am saying that the underlying can be both. The underlying can be both, which is essentially a bond price or the interest rate. Obviously, it cannot be both simultaneously, but it'll be kind of either the bond or the bond price or the interest rate, but one of the two that comes in. Now you have the rest of it. If you look at the rest of it, if you look at the rest of it, you can see I have the same thing. I have an underlying. I have the maturity date of the option, right? You have what you have in as F is the forward price of the contract with maturity T, and therefore the value of F today is going to be the value of the contract is going to be, the current value of the contract is going to be F naught. I'll explain PTT in a minute. The value of V at time t is Vt, and sigma is the volatility of F. Now, what is PTT? Well, PTT, as I've said, is the price at time t of a zero coupon bond that pays $1 on maturity. What does it mean? It is basically nothing but the discount factor. Now, in earlier scenarios, we had actually assumed that the interest rate was constant, right? In the earlier setup, we had assumed that the interest rate was constant, and therefore we kind of went with the model that, okay, if the interest rate is constant, we know exactly how much is going to be paid out, and therefore there is really no problem in the whole story. The problem here is I cannot assume interest rate to be constant because fundamentally, if the interest rate is constant, then there is no point of having an interest rate option. You know exactly everything. The interest rate is obviously going to be changing. So therefore, we cannot assume R to be constant. Right? We cannot assume R to be constant. However, we need to still know the discount factor, discount rate, because we need to calculate the present value of a future payoff. What are we saying, therefore, that effectively that just because we don't know R, or just because R is not a constant does not mean that R does not exist. What we are saying is it's a different R on different days. So on day T, this factor will actually incorporate the R, and that is how we will actually get the value of R or the value of PTT. So PTT is nothing but the discount factor. So which is so if you take continuous time, then it is going to be e to the power of minus RT, actually capital T minus small t. And if you take a discrete factor, it is going to be 1 divided by 1 plus R raised to the power of capital T minus small t. So that is what it is. And now obviously you have an R. The only point that you have to remember in all of this is that R will keep changing, that R will not be the same. So it is the discount rate is valid on day T, the day you are kind of calculating. Right? Sorry, what happened? Oh, okay. Now, like the Black-Scholes model, here also in the Black's model, we make the same assumptions. So we take Vt to follow a log normal distribution, and we take the standard deviation of the log of Vt to be sigma root t. The expected value, and we then know that the expected value of Vt standing on the first day is obviously f naught, because that is nothing but the forward value of Vt. So therefore, what if you take a call option? What will be the only thing we are now saying is we know that the premium is nothing but the present value of the expected benefit on maturity. Now, if on the expected value, Vt is the value or expected value on maturity, then Vt is the value on maturity. Then how much is the payoff from a call option on maturity? Maximum of Vt minus x at 0. Whatever be Vt is in the, whether you write Vt as bond price or you write Vt as interest rate, it is going to be the maximum of Vt and max of Vt minus x at 0. So now if I can calculate that this is the value of the bond, value of the option on maturity, the benefit from the option on maturity, what will be the value of the option today? Nothing but the present value of that. So that is how we want to calculate that. So we want to calculate the benefit, the expected benefit on maturity. And once we know the expected benefit on maturity, we can then simply calculate the present value of that today to calculate the value of the option. So if you look at the equation below that, the expected payoff, and this is very similar to what we had in the Black-Scholes equation, except that now there you had x naught and all of that. But what we are saying is now we are looking at the payoff at maturity, which is the time t. So therefore, instead of s naught, you will get expected value of st, which you replace by expected value of vt out here, nd1 minus x nd2, because remember x is the payoff. X, when you discount it today, it becomes x to the power of minus rt, but x is the future value. So essentially it is x nd2. Now, where everything is the same, d1 is exactly the same. If you look at it, it's identical to what we had in the context of the Black-Scholes. Only difference is that instead of r plus sigma square by 2 times t, the r, because it's not a constant, that is what you're playing around with, is actually dropped from that equation in d1. The rest remain exactly the same. Now, the expected value of Vt is f naught. So therefore, you can put this number in, and if you see the square bracket, what you'll end up seeing is the expected benefit from exercise of the option on maturity. Now, if that is what the expected benefit of maturity is, today is time 0, your option will mature at time t. So therefore, by that logic, the PTT equation will become P0 capital T. And once you have P0 capital T in place, that the rest of it will be simply discounted. And as I said, when D1 is given by this expression, and D2 is given by whatever the other D1 minus sigma root T expression. One could extend the story to the put value, and one can easily see that the put value is nothing but given by that expression, where again D1 and D2 is exactly the same as the earlier case. It's just that now you look at minus D1 and minus D2. N is the same argument, is a cumulative density function of a normal distribution, and the rest of it. So therefore, you kind of address that in that sense. What is the last line? The last line is basically saying, and this is the point I was trying to make. So if it was a bond, if V was a bond, the bond would be given to you immediately on maturity of the option, and therefore that would be the benefit that you would earn. In the context of a pure interest rate, what would happen? The interest rate will only come to you, or the benefit from the interest rate will only come to you at a later point. It will not come to you immediately. It will come to you at some point in the future, right? So therefore, you will have to discount the thing not till the life of the option, but till the life of the borrowing or the lending. In other words, the option life plus the borrowing lending life, whichever one you want to take, is what matters. So therefore, the benefit will actually accrue to you at that point. So it's like this: I have a 1-year option which allows me to borrow at 10% or market rate, whichever is lower, for another 1-year period. Now, let's say the market rate actually goes to 12%. This contract therefore allows you to borrow at 10%. You make a benefit of 2%. But when do you realize the benefit of 2%? Only on maturity of the option of the borrowing period, when you have to repay. So effectively, the life T star therefore then becomes 12 months of the option life and another 12 months, which is the interest rate contract. So therefore, you discount this at T star, which is 24 months or 2 years, and not at 12 months or 1 year, whatever the earlier case may be. Okay? So that is what it kind of implies. Now let me show you an example. And as you will see, if you take a bond, the example is exactly similar to what we did yesterday and earlier with respect to dividend paying, non-dividend paying. So if I take a bond, so what I've done is I've taken a 10-month euro, I'm trying to price a 10-month European call option on a 9.75-year bond. So one of the things that you also have to remember out here very clearly is that the life of the option or life of the derivative cannot be more than the life of the underlying instrument. Because if the life of the derivative is more than the life of the underlying instrument, then basically by the time the derivative of the option comes for exercise, the underlying instrument may not exist. So that bond may not be valid. The bond may have expired, and therefore the underlying may not actually exist. So for the underlying, so it has to be necessary that, or it is necessary that the life of the underlying is at least equal to the life of the option. Preferably, the life of the underlying should be more than the life of the option, which is what is happening out here. And then what you know is this is a 10-month 9.75-year bond, which means there is a the bond has a current face value, which is it's 1,000. The bond has a market price currently trading in the market at 960, and the strike price you're setting it at 1,000. And we are saying both the current price, and the value that you have set up. Right? So all of these are cash prices. What does it mean? Remember, I mean, we haven't done this, but you all know this, that in the bond market, you have two issues. You have a clean price and you have a dirty price. The dirty price is the clean price plus the accrued interest. So it is not that the cash price is the dirty price. It does not mean that the bond options can only be priced, or interest rate options can only be priced when you have the dirty price in the context of the bond. What it means and what you need to have is You can have clean prices, you can have dirty prices. But if you have clean prices, then all the values need to match up to the clean price. If you have dirty prices, then all the values need to match up to the dirty price. And all the values need to be kind of given in the dirty price model. What you cannot have is one clean price and one dirty price. Okay. Again, you have the rest of the information. The only other thing is now the lower half. Now, in this bond, now I'm telling you, you know that a coupon of 10% will be paid in 3 months and 5 months and in 9 months' time. So the next coupon which will be paid is in 3 months' time, and the one after that will be 9 months from today. The option realized expires after 10 months, right? So what happened, and then what I know is the current 3-month rate and the current 9-month rate. So that is 9 and 9.5% that I have in the process. So what do? I calculate the present value of these two coupons that I will receive, 90 and 50 in 3 months, 50 in 9 months, and that is how I've computed that. Interest rate is 9%. So and the 9.5%, which is what I get from the lower half or lower part out here. Time is 3 months, 0.25, or 9 months, which is 0.75. And if you add that, you'll end up getting 95.45. What do we do with this? We subtract it from the current price of the bond. Why? Because remember, the current price of the bond is nothing but the sum of all the present values of future cash flows. Now, under no circumstance will these two cash flows come to the option holder. And therefore, these prices, these two values do not help the option holder. So we discount that out, right? So we take that out from the equation and therefore recalculate the bond forward price, which is the current price, which includes all the cash flows, less these two cash flows, which basically means the remainder of the cash flows as of today, forward value it by 10 months to get what the future value is. And you get that to be whatever, 939.68. Now you have all the other values. You have the strike price X, the volatility 9%, time is 10 months, 10 by 12. You also know today's P0T, because today's 10-month interest rate is given to be 10%. If you go back and look at it, today's 10-month interest rate today is 10% per annum, and the time is 10 months, which is 10 by 12. So therefore, if you compute that, you'll end up getting that value of 0.92. So essentially, the discount factor is 0.92. You know everything else. You just plug the equation in. So I've not solved it, but now you take the Black's formula. You know all of what is D1. You know theoretically what is D1. Once you know here, but you also know the numbers. So plug in the numbers, calculate D1, calculate D2, then calculate ND1 and ND2. Once you've calculated ND1 and ND2, multiplied by F0, which is what you've on one side, and X by another one by X, which if F0 you've computed, X was given to you. So you have whatever is inside the brackets. And once you know what is inside the bracket, you simply multiply it by the discount factor, which is P0T, and that becomes the value of the option that you have. So that is how this is for a call option. The story for the put option will also be exactly the same, except that the mathematical formula will be slightly different. But that hardly matters. You can easily compute the value because, yes, it's a put option, so the formula needs to be slightly different or needs to be adjusted for that fact. But the input parameters are the same, and therefore you can easily compute the value and get that. Right? So that is what the Black's formula is. Now I also want to show you something called, okay, this is also really interesting out here. What happens is, so let's take a simple interest rate option, and let's say it's the floating rate is LIBOR. I know LIBOR is no longer going to be valid, or we are moving into the SOFR regime, but it's easier. All of us will understand what the LIBOR is much easily. So let's kind of work with that. Now what I'm saying is that I have a 5-year. If you look at the lower part, I have a 5-year period over which I'm borrowing. And I'm saying that this, instead of looking at it at 5 years, I'm dividing the 5 years into 3-month intervals. So how many 3-month intervals will I get for 5 years? So every year you'll have 4 intervals, 3 months, 3 months, 3 months, 3 months. That 3 months will add up to a year. And now you have 5 years. So you have 20 consecutive 3-month, non-overlapping 3-month intervals that cover this entire 5 years. What we are now saying is that at every point of this 20 intervals, we will check what the interest rate is in the market, and we have a cap rate of 8%. In other words, what we say is that if it's a borrowing, right? I'm trying to borrow. In this case, I'm trying to borrow. If I try to borrow, then I will borrow at the market rate or 8%, whichever is cheaper for that 3 months. For the next 3 months, I'll again reset the process. So I'll always borrow at the market rate or the cap rate, whichever is cheaper. If I was a lender, if I was taking a put option, then I would essentially price it at exactly the opposite way, because, right? Because so here you're essentially pricing it as the higher of the cap rate and the lower of the cap rate and the market rate. When you are lending, when you are effectively equal to selling, you would want to price it at higher of the cap rate and the market rate, so that you get a better deal in the process. So that's what I do. And I'm saying, since I'm looking at quarterly, any payment that gets generated is made on a quarterly basis. What does this do? This gives me an insurance against floating rate going above 8%. And that is essentially something like a cap. That's the maximum that it can go to. And therefore, that is what is called as an interest rate cap. Now, you can have one single interest rate cap for the entire period, but the way it is done is that this interest rate cap is broken into small bits. In this case, 3-month intervals. So one interest rate cap in this context will be broken into 20, because there are 3 months each, and then for 5 years. So 20 individual caplets, CAPLETS. So I have 10 individual caps. Right? So that is what we kind of look at out here. So therefore, let's look at this. Sorry, let's go back 1 second. So it's 10 million, 8%, 5 years, and then all of that. So let's say on a payment date, or sorry, on a particular reset date, this value has gone to 9%. You can't see it out there, but in that logo, but it has gone to 9%. What happens? The floating rate payment will therefore be 3 months, 0.25, 9 million, 10 million into 9%, and that works out to be 225,000. On the other hand, what is the cap payment? Remember, the cap would then lock it in at 8%, so that works out to be 200,000. So the benefit from the cap, therefore, works out to be the difference of the two, which is 25,000. The question now is, when will the 25,000 be realized? At the beginning of the period, at the end of the period. When do you think the benefit of this 25,000 will be realized? Will it be at the beginning of the period? Will it be at the end of the period? Right? So this money is going to come to you at the end of the period. And only if this 25,000 you are better off if the LIBOR rate is above 8%. If the LIBOR rate is below 8%, then there is nothing, because then you're going to borrow at the LIBOR rate itself. Right? Now, these small bits are what are called as caplets. And let's say these caplets are, so basically you can reset it at end periods in between, T1, T2, Tn at the points at which you are resetting or recalculating the interest rates. So in our example, T1, if you start at 0, T1 is 3 months, T2 is 6 months, and so on and so forth. And Tn is 5 years. So now if I want to write it down, RK is the interest rate for the period Tk to Tk plus 1, so that for that period, as you are observing at the beginning of the period, which is at Tk. Rx is the cap rate, L is the principal, T is the time total life. So at Tk plus 1, how much will be the payoff? L into the time period. The time period is what I call as delta K. So as you can read from the next slide, delta K is the duration from Tk to Tk plus 1. And how much am I going to get? Maximum of RK and RK minus RX and 0. So the benefit is, with which rate is higher? If the market rate is higher, market rate minus cap rate, that is the additional benefit that I'm making, because I can then do it at the cap rate and 0. If not, then essentially there is no benefit to be made. So if you look at what I've written as equation 1, that is basically nothing but represents a payoff from a call option on the underlying interest rate. The underlying interest rate here has been taken as LIBOR, with payoff at LIBOR, which is observed at TK, and the payoff happens at TK plus 1. Now this is for one period, but remember there are 20 or n such period, n such payoffs. So therefore, I can add them up, and each one, equation 1 represents a caplet, and the cap is the sum of the caplets. So what can I do? I can simply value the caplet. I can go and take the same expression that I had from the previous one. I can take the Black's formula and I can solve for it, and I can calculate the value of the caplet. If you've got the value of the caplet, to get the value of the cap, you simply have to add all the caplets together, values of all the caplets together. That will give you the value of the cap itself. Right? So the value of the cap is nothing but the sum of the value of the caplets. Also, you see out here, because it's a pure interest rate, and since the benefit, though you are observing it at TK, the benefit comes to you at K plus 1. Therefore, the discounting happens not with P0 TK, but P0 TK plus 1. So that's another interesting thing that you'll actually have to look at, because it will actually, the benefit is accrued at the next point, and therefore the discounting factor will have to account for that. Okay. Now there are two, so FK and all of that, there are two problems that you kind of end up having. The first one is that where do you get SK from, and where do you get sigma K from? Well, FK can be obtained from the zero coupon yield curve that we have. So essentially, if we have the spot curve, from using the spot curve, there is a way by which you can calculate the forward rates. So that's not so much of a problem. But the second part is that you need sigma K, which is nothing but the volatility of the forward rate. And then that is extremely difficult to kind of get. The usual approaches that in such a scenario that happens is you use the same volatility for all. Right now, you can, in practice, you can kind of use the same volatility for all the caplets in the cap. Typical assumption like Black-Scholes, you can extend that to Blacks, and you can work with that. These are what are referred to as flat volatilities, but this is questionable, particularly if you have a long duration product. On the other hand, you can use volatility, you can use a different volatility for each of the caplets, referred to as the spot or the forward volatilities, and the volatility curve that has to be estimated. But this is actually a far more challenging proposition, so the first one becomes far easier. However, if I can estimate the different volatilities, I can definitely go ahead and do with this. And therefore, as you see, there's a next bit is essentially swaptions. But let me first do swaps, and if I do have the time, then I'll come back and do the swaptions bit. Otherwise, I'll just finish off with the swaps. But what you see in this whole process is the interesting thing that it is not, it can happen. It is doable. Again, the argument of the same volatility may not be taken. The model will work. The model can be adjusted to take into account the fact that volatilities are not the same, but estimating those volatilities and therefore trying to be able to implement it in that process is actually very, very difficult, and that sometimes does create a problem. Okay, so let me now move into swaps. Sorry, not this. This is inherently the last. This is inherently the last bit of the material that I want to cover, and then the last bit, obviously, after this is the presentation. So, what is a swap? So, before I get into this, IRS stands for interest rate swap. Let me first define what a swap is. A swap is nothing but a contract under which you exchange cash flows based on some parameters at different points in time, at pre-decided points in time, not even different points in time, at pre-decided points in time. Right? Um, so I know exact, and it is tied up to some benchmark, it is tied up to some model, it is kind of, it is the payoff that will happen at those pre-decided points in time as per a pre-decided formula. So please remember that swaps Please remember that swaps are not a funding tool. Swaps will not give you cash. Swaps will not allow you to kind of generate cash. What does a swap do? A swap will allow you to change the nature of the cash, to change the nature of assets or liabilities. So basically, it will allow you to exchange the mechanism, but it will not create or it will not generate a mechanism by which you can generate cash in the process. Now, the simplest swap is what is called as an IRS or interest rate swap. That is why I have it as IRS. IRS is interest rate swap. And the very simple model of that is that on one side I have a fixed interest rate, and on the other side I have a floating interest rate. So an interest rate swap, a fixed to floating interest rate swap, is basically a contract between two counterparties. And as you can see, that provides for regular exchange of payment between the parties. One counterparty pays the fixed rate of interest, while the other pays the floating rate of interest. Now, and the last statement is only applicable in the context of interest rate swaps. In the context of interest rate swaps, the last statement is there's only the last statement that matters. Well, only the context of interest rate swaps, the last statement matters, which is that no principal is exchanged. The principal is what is called as a notional principal, and that's not exchanged. Because what is happening is that you want to borrow $10 million, I also want to borrow $10 million. It is that you borrow $10 million on a floating rate, I borrow $10 million on a fixed rate. And now, because of a variety of reasons, we want to swap our positions. So our fundamental exposure of $10 million does not undergo a change. That remains the same. However, what changes is, now if I take the $10 million fixed, which means my payout would be a fixed rate. If I have swapped it with somebody else, with you, who had on a floating rate basis, and who wants to convert it to fixed rate, what will happen is that I will take over your liability of 10 million and pay you the amount that you would have to pay on a floating rate basis. In return, you would take over my fixed rate liability and give me the money to take care of the fixed rate process. So in effect, as you can see, therefore, that though I have a certain exposure, this allows me to kind of talk to, this allows me to kind of change the basis that I have. So if I believe that floating rate is better for me, but for some reason in the market I cannot borrow floating rate, I have to borrow fixed rate, or I have other compulsions, this is a mechanism by which I can take advantage of that. Right? And because the principal is, the amount is the same, the currency is the same, there is no question of exchanging the principal. It doesn't add any value, and therefore the principal is not exchanged. However, in the context of a currency swap, this is not true, and therefore principal will have to be exchanged. That comes later. But in the context of an interest rate swap, which we can safely assume that the principal, we know the principles are notional, and therefore they do not add any value to the process. Right? So this is how it happens. If you want to see, this is the simple plain vanilla fixed to floating interest rate swap. This is how it happens. There are two companies, A and B. They entered into a contract on April 1, 2012, where an IRS where a company A will pay a fixed 5% fixed rate of interest semi-annually for 2.5 years. on a notional principal of $100 million, and bank B in return will pay the 6-month LIBOR. So diagrammatically, this is what is happening. Now what happens? How does the cash flow happen? This is what happens. Now one minute, who pays whom? A pays B fixed. So therefore, you look at the third column, look at this column. Payment from A to B is 5% fixed per annum, payable semi-annually, and therefore it is 2.5% every 6 months, and that is what I am paying in that process. So that is the cost I am paying. Now, in the context of the floating rate, see what I'll do is I'll observe the floating rate today, and that is the rate at which I'll pay for the next 6 months. So if today I am on 1st of April, I will take 4.8%. If the 6-month LIBOR rate is 4.8% today, my interest rate will be calculated at 4.8% basis. But when will the interest be due? Beginning of the period, end of the period. When does the interest become due? At the beginning of the period and the end of the period. The interest becomes due at the end of the period. So therefore, though I've observed the interest rate at the beginning of the period, the interest will become due at the end of the period. This is the 6-month LIBOR annualized. Therefore, the 6-month amount will be half of that, and that is what you see out here. So half of this. So if you take each one and divide it by 2, you get this thing. So A is paying B 2.5%, B is paying A 2.4%. So in effect, net payment from A to B, so a net payment that A makes and B receives is therefore the last column, which is simply the column on A minus column on B, and therefore you can see wherever A is higher, A is paying, wherever A is lower, A is a negative sign, which means A is receiving. And that is how those payments are kind of taken care of. Now, what happens? So this is what will kind of be done. Now, I'll just come back to the fact that how did I get the fixed rate of 5%? I'll come back there in a minute, but that is how this is computed. Now, typically the market makers, so you can compute the 5%, but life is simple because there are market makers in the process and they kind of give you fixed bid and offer rates against the LIBOR. And the swap rate is nothing but the average of this bid and offer rates. So basically, if you borrow, you pay a certain rate. If you lend, you pay a certain, that's what your bid and offer rate is. So the swap rate is the average of these factors. And that value is available in the market, so that becomes easy. So as you can see out here, in the market quotes a bid of 6.02% and an ask of an offer of 6.08%. The swap rate then is the midpoint of the two or the average of these two, which works out to be 6.05%. What does a bid and offer mean? The bid rate means that the market maker is ready to do a deal with you in which he will pay a fixed of 6.02%, in return receive the LIBOR, the floating rate. And similarly, the offer rate means the market maker will be happy to receive 6.08%, and against which he will pay the LIBOR or the floating rate. So the swap rate is taken to be the average of the two, but in a sense, the bid rate is the rate that the market maker is ready to pay. In return, the bid rate is a fixed rate that the market maker is ready to pay in return for the floating rate, and the offer rate is what the market maker is ready to receive, in against payment of the floating rate. So that is what this kind of implies. Who is the market? Now, why do I need a market maker and who is a market maker? Well, ideally, if you are doing a swap deal, the two counterparties need to know each other, and then therefore, you can actually contract, you can run the deal. However, in most cases, it is going to be unlikely that you will know who the counterparty is because you don't know who else needs it at what point and how much. That is where an intermediary is required, a financial institution or an intermediary is required, who will kind of help you find out the other person and help you take the opposite position in the same in that equation. Now, also what happens is many times, particularly for large transactions, You want to do a transaction, there is nobody at the other side. So the market maker says, okay, I will be on the counterparty and do the deal with you. And then tomorrow, when I find out another counterparty on the opposite side, I will do the opposite deal with him or her, and therefore offset my position. Right? On one hand, I will receive floating; the other hand, I'll pay floating. The rates are set on the same benchmark. So the 6-month LIBOR on both days will be the same, except that on one side I will pay 6-month LIBOR, on the other side I will receive 6-month LIBOR. So my net payoff in the story will actually become zero. Right? So basically, this is what a market maker is, and that is what a utility is. So these large financial institutions typically act as market makers, which in simple terms means that they are ready to enter into a swap without having an offsetting swap with another counterparty. But but once they do it, they will then go and try to look for a counterparty and try to exit from it. I mean, in the worst case, if they cannot exit, they will keep it on their books, but their primary objective will be to exit from it. Now, what are the uses of swap? The primary usage of swap is to transform a liability from a fixed rate to a floating rate or vice versa. And this will allow you to hedge yourself against the potential of rising interest rates. Why? Because if you are a borrower on floating rate and if you believe floating rates will rise, that means your interest cost will go up. Now, you may not be able to sell down the asset in the market because of a variety of factors. Obviously, that is one way to address your risk. But you may not be able to sell down the portfolio in the market. So what you can then do is you can go and find out somebody else who has the opposite view to you and therefore says, okay, I will be ready to kind of take over the floating rate liability. In return, you take over a liability of an equivalent amount, which is a fixed rate basis for it, which you may not be that uncomfortable kind of taking up because that is kind of a fixed amount. Now, if I can do it for the liability, I can also do it for the asset. So if I believe that the interest rates will fall, this will be a mechanism for me to hedge use the hedge the floating rate to change the nature of the asset from floating rate to fixed rate and therefore hedge against the risk of falling interest rates. A little more complicated, but one could do is, you could also transform the asset. You could also transform the asset from floating rate to fixed rate against the falling. You could also alter the duration of the portfolio of either the assets or the liabilities. So you could actually change the duration of the assets and liabilities, and in a sense, it will also therefore allow you to reduce your borrowing costs. Now, how do you use an interest rate swap to hedge against risk of rising interest rates? This is how, because that is the primary utility. What one of the primary utilities? What can you do? You enter into a fixed to floating IRS and you pay fixed, receive floating. Because when you pay fixed, it permits the firm to transform an existing fixed floating rate debt into a synthetic fixed rate debt for the remaining life of the bond. Because if you look at this, floating rate debt plus fixed rate debt is a synthetic fixed rate debt that you kind of get. So when you pay fixed, you are actually and you receive floating. What happens? Though you have a floating rate debt, you are because you are paying fixed, receiving floating. The floating debt inflow and the outflow matches each other, and therefore there is no liability. And what you are left with is a fixed rate debt in the whole process. Similarly, if you want to hedge it against falling interest rates, then what you would do is you would enter into a synthetic fixed rate asset. So if interest rates are falling, you would want to and you want to protect yourself against that, you would want to pay floating, receive fixed. Because once you receive fixed, which means your income is constant, and you pay floating, which means as the interest rates change, your amount you are paying out changes. You are expecting the interest rate to go down, and therefore the amount you have to pay also changes or moves downwards. How can you, there is also this thing about duration. How can you change the duration of your portfolio of assets or liabilities? Well, duration of life of the LIBOR floating rate bonds is essentially what is the reset period. So that is the maximum duration of the thing. So obviously you can change the duration by converting a part of the fixed rate bonds into floating rate bonds by using IRS. Similarly, you can increase duration by converting a part of the floating rate bonds into fixed rate bonds by using IRS. Right? Let's look at an example out here. Let's say a company gets a AAA rating and company B gets an A rating for a long-term bonds, and their borrowing rates from the Euro market and Euro banks are as follows. I'll show you. Now, company A wants a floating rate loan and company B wants a fixed rate loan. So this is what happens. A can borrow at 8%, and this is one of the reasons why swaps exist. You look at this. A can borrow in one market, in the Eurobond market at 8%, and it can borrow in the Eurobank market, another market, for LIBOR. So basically, it can borrow in the fixed rate market at 8%, and it can borrow in the floating rate market at LIBOR plus 50 basis points. On the other hand, B, which can borrow at 9.5% and 6 months LIBOR plus 120 basis points, which is fine. And then on the face of it, it is fine because A is a AAA rated client, B is an A rated client. So the AAA rated client has a lower credit risk and therefore enjoys a lower cost. Right? Yeah, echo is coming because one of you have the. Yeah, now it's fine. One of you had your mic on. Is it fine now? Yeah, okay. So please, if the others keep it on, then there'll be a problem. Otherwise, there'll be no echo. But look at this. Let's go back to this and look at this. In the fixed rate market, company A enjoys a benefit of 1.5% over company B because company A can borrow at 8%, company B borrows at 9.5%, and therefore company A enjoys a benefit of 1.5%. On the other hand, in the floating rate market, the benefit is only 70 basis points, 0.7%. Because it is 6 month LIBOR plus 50 basis points, 6 month LIBOR plus 120 basis points. Therefore, there is only 70 basis points. Whereas on this side, it's 150 basis points. And this is the problem. This is the basis on which swaps will happen. The two companies are the same. The borrowing amounts are the same. Everything is the same. The only thing is that instead of borrowing in the fixed rate market, you're borrowing in the floating rate market, and that is causing a difference in the spread between the two companies is changing because of that. Which I'm sorry. Which means what? That given the creditworthiness, company A is necessarily better off than company B on an absolute basis. However, on a comparative basis, on a simple comparison between A and B, B is better than A in the floating rate market than in the fixed rate market. And why? Because in the floating rate market, B has to pay a premium of only 70 basis points over what A's cost is. And the same point in the context of the fixed rate market is 150 basis points, 151.5%. So necessarily, that is an anomaly, and that is what I want to play around with in the context of swaps. So remember what they also wanted in the previous slide, and this is also important. A wanted a floating rate loan and B wanted a fixed rate loan. So what I'm going to do as a market maker or a dealer is to kind of tell just to tell A that look, you want a floating rate loan, which means you are ready to pay 6 month LIBOR plus 50 basis points. And similarly, B wants a fixed rate loan, therefore you are ready to pay 9.5%. Now I will tell them do what I tell you to do, and in the process, if you do what I tell you to do, I will reduce your borrowing costs. How much can I reduce it by? Remember, there is a 1.5% difference out here. There's a 0.7% difference. So the difference between the two spreads is 0.8%. So I can kind of say in simple terms that the 0.8% is what I divide by 2 equally. So that becomes 0.4% each. So essentially, I will do a structure under which A's cost will come down from 6 month LIBOR plus 50 basis points to 6 month LIBOR plus 10 basis points. B's cost will come down from 9.5% to 9.1%. How do I do this? Okay, I have also put it up the intermediary. So let's say obviously the intermediary or the market maker will not do it free. So the market maker charges 20 basis points. So out of the 80 basis point that is there, 20 basis points goes to the market maker. And now I say, okay, I will take the 60 basis points and I will divide it equally. So if I divide it equally, what will happen? Company A's cost should become, net cost finally, should become 6 month LIBOR plus 20 basis points. Company B's cost should become 9.3%. Sorry, 9.2%. Let's see if that happens. This is what happens. I make company B. So I make company A borrow at the fixed rate market. So if we look at the downside out here, company A borrows at 8%. The financial institution now pays company a fixed of 7.8%, which means, I'll take the other side, which means in terms of it's earning 7.8%, it is paying out 8%. So it is losing 0.2%, right? And therefore, that is the cost for A. A also pays out LIBOR. L is LIBOR, 6 month LIBOR. So A's net cost therefore becomes LIBOR plus 0.2% or LIBOR plus 20 basis points, which as we know is 30 basis points lower than what it would have paid if it went into the market directly. What about the other side? Now the LIBOR that A pays the financial institution, now I make B borrow in the market. And when B borrows in the market, how much does it pay? LIBOR plus 1.2%. Now I make so the LIBOR that the financial institution get from A is passed on to B. So therefore B has an income of LIBOR and at this point an outflow of LIBOR plus 1.2%. If you add these two together, obviously therefore it has a net cost of or net cost of 1.2%. And it also pays a cost of 8% to the financial institution. So therefore its net cost is 8% to the financial institution and 1.2% is the difference between the LIBOR it receives and the LIBOR plus 1.2% it pays out. So the net cost for B becomes 9.2%. And as you see, it was ready to pay 9.5%. Now if it gets it at 9.2%, it will obviously be happy to take it. And therefore you have a scenario where both A and B have benefited, both of their prices have come down, both of their costs have come down from what they were ready to pay. And therefore they're both better off in that sense. And if you look at the financial institution in the center, on one hand it's earning the LIBOR and passing it through, but on the other hand it is earning 8% and passing 7.8% on the other side. So there is a 0.2% or 20 basis point which they are earning as kind of a facilitator of the deal and all of that. And that is how this kind of structure works or continues to be there. So this is the example of that. So as I said, whatever I told you out there, this is the working of that argument out here. Now, therefore, one can kind of write down an IRS as nothing but the difference between two bonds, so a difference between a fixed rate bond and a floating rate bond. Right? So therefore, if you look at it, two companies A and B agree on an IRS or to an IRS on a notional principal of 10 million for a period of 5 years, such that A will pay 5% per annum fixed and B will pay 6-month USD LIBOR rate of interest. Right? So, in this story, the principal amount is not exchanged, and we can safely assume that it's not exchanged. We can safely assume the exchange of principal amount is the end of the life of the contract without changing the value of the swap. So because what it means is that ideally I should be exchanging my principal and continue to pay on that and then re-exchanging it. But effectively, I don't have to worry about that, and I just simply continue in that manner. The only difference is in terms of the interest payment part of it that is managed on the other side, and therefore it is not what you want, but what is better for you is the model that is chosen. And then one can, if there are two players, you can kind of easily sit them down. Right? Now, fixed to floating is difference between two bonds, and it can be basically company. If you look at that, company A has lent $10 million to company B for 6 months at the USD LIBOR rate. Company B has now simultaneously lent $10 million to company A at the semi-annual fixed rate of 5% per annum. Now, obviously, I give you 10 million, you give me 10 million. Now, what is the point of this exchange? That doesn't make any sense. But subsequently, the other amounts are not the same because 5% on 10 million, 6 monthly payments is not necessary because I do not know what the LIBOR evolution is going to be. So, LIBOR evolution may be straightforward, may not be that straightforward, and to that extent, I will actually have to adjust for it. So, there is no point exchanging the principal, but there is obviously, I mean, the interest will obviously have to be exchanged as we go along, right? Now, obviously, if you plot an interest rate curve of based on the LIBOR rates, what you will end up getting is essentially a LIBOR zero curve. If you plot that, you get a LIBOR zero curve, and then you can kind of take the zero rates can be obtained up to 1 year from the interbank borrowing rates, 2 to 5 years from the futures rate, and for longer maturity from swap rates, because you do not have long maturity, interbank borrowing or futures contracts. So like 10 years, 15 years, you don't have, whereas you have 10 year, 15 year swap rate, so that can be used to estimate that. So this is what I have kind of already highlighted. So, if the swap rate is used as a fixed rate, the value of the fixed rate bond at the swap is the swap principal. So the swap rate is nothing but a LIBOR at par yield. But anyway, you can ignore this part. You can ignore these slides. Okay. So how do I kind of get the fixed rate? So look at this. This is how I get the fixed rate. Suppose the floating rate, the LIBOR curve, is these values: 5.5, 5.75, 6, and 6.2%. Then what is the equivalent 2 years fixed rate on this side? We just equate the present value of the cash flows. Because the deal in a swap, irrespective of what type of a swap it is that the NPV of the swap has to be zero at the time of the start of the swap. So at initiation, the swap will be zero. The value of the swap will have to be zero. In other words, the value of the fixed leg and the value of the floating leg have to be equal. So we are basically using continuous compounding as assumption of discounting. So if you think of it, if I take LIBOR of, so I'm taking LIBOR at, I'm taking this and I'm saying, okay, let me calculate this. So how did I get the, so this is, it starts from here. Okay, let me leave that. So this is a bond that pays me 6.2% coupon. So I want to find out the value. So it is paying me 6.2%, right? And I discount those cash flows. Look at it. I know that I actually know that the values at 6 months, 1 year, 1.5 years, 2 years. I know, so I can add. So this is kind of working it back to 100. Now let me assume that R is a 2-year LIBOR zero rate. So I can kind of work from here. This is paying at par, and therefore I can kind of take the value and I find out what the 2-year rate is. So I know so basically here I know the 6-month rate, the 1-year rate, the 1.5-year rate, and I can use that to calculate the 2-year rate if I know what the value of the bond is in the market. And because the value of the bond here would be par, so therefore the face value which is 100, and hence I can easily compute that value in that process. Now, mathematically, I mean, how do I kind of mathematically value it? This is how I do it. I have the value of the fixed rate bond underlying an IRS. I have a floating rate bond underlying the IRS. So the value of the swap. Now this you will obviously will change from the company to company. So here is the value of the swap to the company who's paying fixed and receiving floating. And therefore it will be his receiving floating value of the floating rate bond less he's paying fixed value of the fixed rate bond. If it was the other way around, if it was like the company paying floating, it would have been BFX minus BFL. Now, how do I compute this? Let me take L to be the notional principal. TI is the time until the IX payments are exchanged. So the IX payment I is less than N. RI is the LIBOR zero rate corresponding to I. K is the fixed payment made on each date. So therefore, the value of the fixed rate bond is this. You discount the Ks. The Ks are the individual cash flows, and on maturity, you are paying the notional principal. So you can add the notional principal and then the corresponding interest rate. You add it up. Look at it. It's nothing but the value of a bond. On the floating rate side, what will you do? Your notional principal is L. TI is the time till the next principal, next payment. RI is the LIBOR zero rate at time corresponding to T1. R1 is the thing. The interesting thing is K star now. What is K star? K star is the floating rate payment on the next coupon, next payment date. Now, once you have made a payment, which means you are in an interest payment date, the floating rate will reset, and therefore the bond will reset to par. Therefore, the value of the bond will always be L. And in between that, what will happen? In between that, what will happen is it will be the face value L plus the amount, the coupon that you are supposed to earn, K star, for that period, discounted to the starting point. So that is what will essentially be the value of BFL in between the payment dates. So therefore, I know exactly what is it. I know on which day I am. If I am on a payment date, then I just say BFX is equal to BFL is equal to L and solve from there. If I am not on a payment date, then I use the second formula to kind of look at that. So look at a simple example. Pay 6% with semi-annual compounding on a swap and receives 6-month LIBOR with notional principal of 100 million. And the remaining payment dates are in 3 months, 9 months, and 15 months. The corresponding zero rates with continuous compounding are 6, 6.5, and 7% respectively. The 6-month LIBOR, now this is the interesting thing, which is one of the things. The 6-month LIBOR at the last payment date was 5.2% with semi-annual compounding. Now, this is what will be paid next. So this will be paid at the 3-month point. What is the value of the swap to the FI? Let's ignore day count conventional knowledge and just take the same thing. How much is K? How much is the exposure? So you see the financial institution pays 6%, semi-annual compounding on 100 million. So it is 6 million annual, so 3 million semi-annual. So the payment K is 3 million. Right? What is K star? K star is the payment on the floating rate side. The last value was 5.2%. That is what you are supposed to pay. So 5.2% by 2 into 100 million, that is 2.6 million. The face value is 100 million. Now the T1 is 0.25, T2 is 0.75, so 6 months, 9 months, T3 is 1.25 years. And what are the interest rates? They are given 6%, 6.5%, 7%. C by C means continuously compounded. So therefore, I can use that to calculate the value of the floating leg, the fixed leg. Similarly, I know the value of the floating leg. So I know the value of the swap is nothing but the difference between these two, which is therefore 0.91 million. I've simply computed them and I've taken the difference, and that is 0.91 million. Right? Now the one other bit. How do you calculate the fixed rate? So, in this example, for example, I told you it is paying 6%. Now, how do you get the 6%? How did I land up with the 6% number? So that is what I want to talk, what we want to kind of also show you. I want to show you out here. So at the beginning of the period and the origination, the value of the floating leg bond will only be nothing but the face value, because after all the interest rate is the same, so it is kind of resetting itself or setting itself at par. So the value of the floating rate bond will be exactly equal to the notional principal L. So what do? We say, okay, you have the LIBOR 0 rates, you find the fixed rate that makes the present value of the fixed payments, the sum of the present value of the fixed payments equal to L. Obviously, you can use the current market rates for the different maturities, 6 months, 1 year, 1.5 years, 2 years, and so on, to use as approximate discount rates, and then solve it from there. So let's look at this. What I know is that the 3-year swap with annual, I want to find out the fixed rate for a 3-year swap with annual payments. Now the LIBOR 0 rates for 1 year, 2 year, and 3 years is 5, 6, and 7.5%. Now, how much is BFX? BFX is equal to the face value, which is L, which is 100. And let me assume that to be 100. I know it's not given there. You could take 1 also, but for simplicity, let me assume 100. So what should be 100? Now I will make a payment of K and 1 year, 2 years, 3 years. So and at the end of it, I'll also pay back the 100. So then this 100 has to be the discount. K discounted over 1 year at 5%. K discounted over 2 years at 6%. And finally, the last payment will be face value plus the interest. So 100 plus K discounted over 3 years at 7.5%. So if you solve from this, you get K to be 7.36%. And hence, the fixed rate is 7.36% against LIBOR. So basically, if I take this and given the information today, I pay fixed, I receive floating. So I will pay at 7.36%, while I receive at LIBOR. Right? So that, and therefore, given this, that I've equated this to, they will obviously have to be equal today, which means the NPV or the PV of the fixed leg and the PV of the floating leg are equal. In other words, the NPV of the swap and origination is 0. Now, this does not guarantee the fact that the NPV will continue to remain 0 going forward. But, if you equate this at that point will obviously ensure that it is equal to 0. Okay, you can skip these. This is so in your slides you will have this. I did not delete it. Now this is another specific thing where you kind of do it on a daily basis. Instead of compounding it over a larger frequency, you compound it on a daily basis. Now this is something which is available in some markets, and in India is a very popular market for this, but this is not something which is very popular elsewhere. Though now with the new SOFR regime, the secured overnight funding rate regime that is coming into place, this might become popular, but at this point, this is not very popular. So I will kind of ignore this for the time being. And then I mean, you guys can ignore this so basically, you guys can ignore slides 31, 32, 33, 34. Now, now obviously, if you can do it for interest rates, you can also do it for currencies with currency as an underlying. And there, the only difference is the currency principal also has to be exchanged and re-exchanged. Because think of it, you enter into a swap between US dollar and Vietnamese, no, VND and USD. Your current exchange rate is, let's say, 23,000. So $1 is 23,000 VND. And therefore, today the exchange rate is $21 is 23,000, and you can easily take that. Now, the value of the dollar after 1 year or after 2 years, whenever the swap matures, does not have to be the same as 23,000 VND. I do not know which way it will move, but it could move up, so it could become 25,000 VND, or it could move down and it could become 20,000 VND also. Now, therefore, when the swap ends, these cash flows will also have to be reversed because the value of the dollar side in the VND will not be the same. And that adjustment also needs to be done. So that is the only difference in the context of a currency swap. So if you look at it, the currency swap involves exchanging principal and interest payments. In an IRS, you are only doing interest payments. Here you are talking about principal and interest payments in one currency for the principal and interest rates payments in another currency. Right? The rest of it kind of work exactly in the same manner in this whole thing. So here is a quick example, and I will kind of probably stop with this example, and there are some examples worked out at the end, but one could stop here also. So let me show you this example. So there are these two companies, IBM and British Petroleum. They have entered into a swap deal on February 1, 2014. IBM agrees to pay a fixed rate of interest of 7% in sterling and receives a fixed rate of interest of 4% in dollars from British Petroleum. Interest payments are made once a year. The principal amounts are $15 million, and which is 10 million euro. So from here, you can actually say that the dollar to euro exchange rate is 1:1.5. Right? So what happens? Initially, the IBM. See, what is it? IBM is an American company. British Petroleum is a UK-based company. So IBM borrows in dollars, passes the dollars on to British Petroleum. British Petroleum borrows in sterling and passes the sterling on to IBM at the current exchange rate. After that, for the remaining duration of the swap, British Petroleum pays IBM the interest cost on the dollar on dollars, which IBM then uses to pay out its customers, its lenders to the outside world. Similarly, IBM pays British Petroleum the cost in sterling, and British Petroleum uses that money to pay out the outside world. And that is how it will kind of work. Finally, at the end of it, the British Petroleum will refund the dollar side, the principal on the dollar side, and IBM will refund the principal on the sterling side. And that is where the exchange rates become relevant or important, because $10 million equal to $15 million equal to 10 million euro, which means that I'm basically assuming, if I take the last one, I'm assuming one sterling is equal to $1.5. Now, at a later point, it may be different, and therefore the equivalent amount could essentially become different in different conditions, right? So, at the outset, as you can see, IBM pays 15 million and receives 10 million sterling. During the life of the contract, what happens? IBM gets the dollars. How much is the dollars? Remember, if I go back, receives a payment of 4% in dollars. So 4% of 10 million, which is 4% of $15 million, not 10 million in sterling, which is $0.6 million is what it receives every year. On the other hand, how much does it pay? It pays 7% on the sterling. Sterling is 10 million, so 7% on 10 million is 0.7 million sterling. At the end of the swap, what happens is British Petroleum has to pay. It's context of IBM. IBM pays $10 million, 10 million sterling, and in return gets $15 million. You could have also looked at it from the British Petroleum side. British Petroleum would pay $15 million and earn 10 million sterling. So these are the cash flows. If you look at the cash flows, 5-year thing, this is what the cash flows are. So in the first period, this is with respect to IBM. Right? These are the cash flows with respect to IBM. Please understand. IBM gives $15 million to BP and in turn gets 10 million pounds. Subsequently, IBM keeps on earning $0.6 million from BP and pays out 0.7 million pounds to BP. At the end of it, IBM earns 15 million pounds plus the interest of that year, which is 0.6, and pays out 10.7 million pounds to BP. The reversal. Right? Now, what are the typical uses? The typical uses are again the same as we had earlier. Conversion of a liability in one currency to a liability in another currency, or conversion of an asset in one currency to an investment or investment or an asset in one currency to an investment in another currency. Now, one quick important thing that I just wanted to highlight out here. While we are talking about this conversion of asset or liability, both in the interest rate and in the in the currency case, you can always argue that why are you doing all of this? Just sell down your exposure in one market, recreate the exposure in the other market. And then at which point you want to reverse, do the reverse. Well, theoretically, the answer is you can do it. Now, there might be practical challenges of you doing it. That could involve that you are not in a position to sell it down because there might be other contractual obligations that are put in place. And therefore, while you might want to sell down, it is not necessarily feasible or allowed. Right? Now, the other reason is, as I said, there is a comparative advantage there is a comparative advantage and therefore market imperfection that is there. Now, why is the market imperfection there? That is, anybody's guess. So basically, the outcome is that because markets are imperfect, this gap remains. Obviously, as markets get more and more perfect, this gap narrows down and you do not have the possibility of making this money. However, as long as imperfections exist in the market, as long as markets are imperfect, right, there is information asymmetry in the market. Both the possibility of having a swap deal exists. Now, as the markets get more and more perfect, as these differences balance each other out, then the possibility of having a swap does not exist any longer. Okay. So, like arbitrage, swaps also exist because of market inefficiency, and as markets become more and more efficient, the possibility of swaps actually vanishes. I've already talked about the comparative advantage story in the context of interest rate. There is this comparative advantage story also that can show in the context of currency swaps. One possible source of the comparative advantage, the example is between General Motors in the dollar market and Qantas in the Australian dollar market. And the argument is that the difference is because of some potential tax. So General Motors wants to, for whatever reason, wants to borrow 20 million Australian dollars. Qantas wants to borrow $12 million, and that kind of ensures that the current exchange rate based on that is 0.6 US dollars per Australian dollar. So 1 Australian dollar is equal to 60 cents in US. So you can have the same thing. General Motors, and I have certain costs. So General Motors can borrow dollars at 5% and Australian dollars at 12.6%. Qantas pays 7% and 13%. And look at it. Qantas obviously pays more in both markets, but in the dollar market, Qantas pays 2% more. In the Australian dollar market, Qantas pays only 0.4% more. So there is a huge comparative advantage. So what happens? Therefore, the 2% minus 0.4, there is a 1.4%, 1.6% benefit that is there, which is happening because of market inefficiency. Because there is no reason for the market to kind of behave in this manner and the market to have it in this fashion. Once that happens, so I take the 1.6%, I then divide the 1.6% into three ways. So, if you look at it, how much is the financial intermediary earning? You see the so US dollar. So this guy, General Motors wanted Australian dollar funding, right? What is General Motors cost? General Motors was charged so 1.6%. So this here the split is 0.7% to General Motors, 0.7% to Qantas, and 0.2% to the financial intermediary. So what do we make? What is the deal? We make General Motors borrow in US dollar market at 5%. The financial intermediary pays General Motors 5% dollar terms, and in return, General Motors pays 11.9% Australian dollar terms, which means instead of paying 12.6%, it is only paying 11.9%. So General Motors is benefiting by 0.7%. Of this 11.9%, that the Qantas has borrowed in the Australian dollar market at 6%, at 12, at 13%. The financial intermediary pays Qantas 13%, so that Qantas's exposure to the outside world is kind of taken care of. In return, Qantas pays financial intermediary 6.3%. So what is Qantas's cost? Qantas's cost is 6.3% in US dollar terms. Direct access to the market would have cost Qantas 7% US dollar terms. So hence the difference, the benefit is 0.7 again. 13% vis-a-vis, sorry, 7% vis-a-vis 6.3%. Therefore, Qantas is better off by 0.7% as well. But that means that if you're taking 0.7% on both sides, the total benefit available was 1.6%. So therefore, you have already used up 1.4%. So the intermediary will only get 0.2% of the exposure. So right? Now, the only thing that you have to be careful about out here and see is, yeah, just one second. Yeah, yeah, Tran, tell me. Or you can ask, you can type your question if you want. You raised your hand. Tran, you raised your hand. You can type your question. Okay, while you ask the question, let me finish this. So the only thing you have to look at is what is happening to financial intermediary. Financial intermediary is earning 6.3% US dollars from Qantas, but paying out only 5.5% to the US dollar to General Motors. So he's earning 1.3% on the US dollars, and he's losing. I mean, we look at the other side. 11.9% is what he's earning. He's paying 13%. So he's losing 1.1% on Australian dollar terms. So his net income is 1.3% plus income and 1.1% loss on the other side. So net income is 0.2%. And now if you add it up, 0.7% to General Motors, 0.2% to the intermediary, 0.7% to Qantas, this adds up to 1.6%, which is the benefit that you were getting. Okay. Okay, so let me stop with this. There is a little bit out here, and I can skip this. There are some examples that you can look at. Let me stop with this. I still didn't get what your question was. Okay, so you really got your hand down. Okay, fine. Let me stop here. And this kind of covers, I mean, I would have probably, if I had a little more time, I would have done shown you those examples, which I don't. Let me stop here because we want to do the presentations. Yeah. Uh, do you have any questions on this up to now? Do you all have any questions up to now? No. Okay, let's do one thing. Let's take, okay, let's do one thing. Let's take a quick break. Let's take a small break. Let's take a quick break. So it's about, it's what, it's 8:30, 8:30, whatever. So let's take a 10-minute break instead of a 15-minute break. And let us join by, so it's about 8:30, 8, close to 8:40 now. So let's join by 8:50 your time. So we'll take a 10-12 minute break. We'll join by 8:30, 8:50 your time, and we will do the presentations. You guys can decide who will, which group. As I said, to me, it doesn't matter. I'm just going to go with the group order, 1, 2, 3, 4, 8 of them. So we'll start with the first. I mean, I would suggest that we start with the first group, and we go in that order. Okay. If you tell me who's group 1, I'll make them the presenter so that they can present, and then we can again, after the first group is over, we can shift to the second group. But in between, we can take a quick 10-minute break. You will present for group 1. Okay, so I'll make you the presenter so that you can kind of, you know, so I've made you the presenter. You can upload your presentation, but we'll start in 10 minutes. Okay. Okay. I'll stop recording for some time and then we'll start.
When you see the screen.
Well, I can't see your presentation. I can see your screen, but I can't see your presentation.
Now can you see it?
No, I think you need to start once again. Okay, let me make you the presenter.
Okay.
Okay, I've made you the presenter. You can go ahead now.
How about now?
Professor Basu, I said Nguyễn Thị Thu Hiền as the presenter, not Nguyễn Thị Thanh Huyền.
I made him the presenter.
Okay.
Nguyễn Thị Thu Hiền.
Yeah, I can see him there now.
Yes.
Yeah.
Yes. Yes, I can see your screen. Good.
Did you see the slide?
Yes, I can see the slides.
Okay. So I can start now. I will present the work of group 3. So first of all, in case we want to assess the risk of a firm, we will start with the risk management framework. So the risk management framework will come first from the risk universe. You will need, first of all, to identify what is the material risk of your firms. Then next, you will assess how much is the risk, how much is the amount of each type of risk. Then you will have a plan to mitigate and treatment for each type of risk. After all, you will need to monitor and report the risk the risks, to keep managing the actual situation, and identify the risks constantly. In order to do that process, you will need tool, resource, policy, procedure, training, risk culture, and system in your firm to do that. After that, you will need to set out your organization structure with the roles and responsibility of each person in the firm to do their their role in the risk management framework. Then you will need a governance framework to oversight the risk process in your firms. Then finally, you will need three line of defense, three line of assurance to manage. Sorry, to oversight what is happening in the first line and second line. So for the firm we are thinking about is a hedge fund, and they are focused on the arbitrage strategy. So we will identify what type of risks they are facing. We identify that market risks are the main risks they are facing. So in market risks, the basis risk is what this firm is facing day to day, because they are trading on the spread of different assets. So basis risk is the imperfection correlation between two investment. Then they will create the excess gain or excess loss in hedging strategy. So in the case that the spread between your long and short position is lower than your expectation, and especially lower than your capital price, it will cost your loss. Secondly is the FX risk, foreign exchange risks. So because of the fund is doing the strategy to short the US government bond and long the government bond from emerging countries. So in case they buy the bond from emerging country in different currency, they will face the FX risk when they convert their return from different currency to US dollar. The third is the yield curve risk. So the yield curve risk is the risk you will experience an adverse shift in market interest rate associated with the investing, especially for the fixed income instrument. Here is the bond. So that are three types of market risks they are facing. The other risks they can be faced other than market risk is first the liquidity risk. Liquidity risk is the risk that your inflow and outflow liquidity does not match. Then it will maybe lead to the capital run out and a default situation. The second one is the credit risk. So from my point of view, that the worst case scenario here, this firm can be faced not about their income can be lower than expected, but the most severe case is that their counterparty is default. So the risk of counterparty credit risk here is very high, especially when you buy the corporate bond, then that corporate is default, so you lost all your money, including the principal and the interest. The second is the settlement risk. The settlement risk is the risk where your counterparty cannot commit with their contract previously. So at that date, you need to pay for your client, but your counterparty did not make their deal. The third one is investment risk. Investment risk is like when you buy the corporate bond from a corporate, but at some point of time in the future they want to buy back. Then suddenly you have a pile of cash, but you do not know what to do with it. So that is the investment risk. Besides credit risk, you have the operational risk, like fraud risk, when your employee trying to scheme your money or trying to do something false behind, or they make some insider trading so they can make your huge loss. Cyber security risk. nowadays your system can be hacked anytime, then you can lose the money. Third party risk, you use the service from other vendor, then the vendor do something wrong, then you lose your money. um, Lastly, is this country risk. Country risk here is because you are buying the bond from an emerging market government bond. So in the case that that country is have some kind of issue, like they have the war, they have the capitalization from the government, they did not want, their bond is default, so or high inflation, then you will facing the risk of loss, losing your money because you're trading cross border. So the way to mitigate that kind of other risks is that can be go through the risk management framework, or using other instrument which we will mention in the next slide. So the second step after we identify the risk is we assess and measure it. So because we identify that market risk is the main risk here. So to assess the market risk, there's two main approach. The first is the VAR, value at risk, and the second is expected shortfall. So in VAR, we have two way to do the VAR is the non-parametric and parametric. Non-parametric, also called the historical VAR. So you try to use your historical data to to assess the value like at some point, some level which you can accept. So to in order to assess the historical data, you can use the age-weighted methodology, or the volatility weighted, or correlation weighted, or filter historical simulation like bootstrapping, etc. For parametric, you can assume your historical data will fall on some kind of some kind of distribution like normal or log normal distribution. For expected shortfall approach, it will provide an estimate of tail loss by averaging the value at risk for some increasing confidence level in the tail, like you will assess the VAR at 95, 96, 97, 99% VAR, then you will arrest them, then you will have the amount of expected shortfall. Then expected shortfall is the methodology is extremely used mostly for some portfolio with the big tail risks. Sorry, big tail distribution of historical data. So after we assess and measure the risk, we will try to mitigate it. So there are some instruments to help you to mitigate and treatment the risk. First of all, you have the future or forward product. So you can long or short the long or short the future or forward on US high yield corporate bond, or long or short the future and forward on treasury bond of emerging market to like hedge your current position. The second is the either option. You can buy a call or put option to like limit the loss. You set out what is your limit of loss, and you buy the option to set out what is the maximum loss you can take. And it's also minus your income a little bit, but it would help to limit the loss. The third one is you can use swap like CDS, credit default swap, to hedge counterparty risk on corporate bond. In that case, you will transfer the risk of the counterparty risk to an hedge fund. The second is you can use the currency swap to avoid the FX risk. The third is you can use the IRS to hedge the yield curve risk. The first instrument here is insurance. So insurance is mostly used to hedge some like not market risk, not credit risk, but it's like operational risk or third party third-party risks. So in that case, you will buy the insurance, then the insurance companies will have you to pay back some money if the severe case happens. For example, you have the earthquake, you have 5 years, something like that, then your risks will be covered by the insurance company. So lastly, after we have the plan for it, for the plan, treatment plan and mitigation action for that type of risks, you will need to monitor it and keep control it. So there are some way to limit and control the risks. First is the risk avoidance and acceptance. Why we accept the risk? Because the risk is coming with the opportunity. So if you want to make the money, if you want to have the opportunity, sometimes you need to accept the risk. The second is risk avoidance. Risk avoidance is like when you need to set out your risk appetite. So for example, I can lose not $5 billion, but I can lose about $10 billion. So if I know that there are some deal can make you a huge of money, but the loss is too high, then you avoid to join that deal. That is the risk of avoidance and risk acceptance. It's been correlated with your risk appetite. The second is loss prevention. As we said, the loss prevention can be can be hedged using the CDS or the insurance. By using that instrument, you transfer your risk to other party. The loss reduction is like you trying to limit your loss by using some derivative product like option for what I have mentioned before. Risk diversification. When you're trading on the market, the first thing you can do is diversify your portfolio. In the case of diversify your portfolio, or if one of your assets or one of your portfolio is going down, then other maybe it's not impact, or maybe it's not lead to the situation that you will be default. So you can diversify your portfolio by belonging multiple corporate bond or multiple government bond in different country, in different currency, and you can set the risk limit to each product, each asset, each trading desk, or each trader. The fifth is the risk transfer. So the risk transfer here is when you use the CDS or the insurance products to transfer your risk to another party. So after beside those kind of risk control way, you will need to monitor your risk by using the risk reporting. You need to reassessment your risk. You will need to audit your risk. You will need to use the variance and trend analysis to assess your portfolio and your risk position. So that is obviously the general view of our general view about this case. In order to go further and more detail, we will put it in our report.
Okay, thank you very much. Quite a good presentation. Very nice. Thank you. And I look forward to reading your report.
Yeah.
One minute. I'll just make you. Where are you? Yeah. Yep. I've made you the presenter now. Bui.
Yeah, good evening, Professor and class. Did you see my screen?
No, I can't see your screen as yet.
You don't see? Yes. I see it's there already. Yeah. You see now?
No, it's just my screen that's showing up. 1 second. let me make you a presenter once.
Yes.
Yeah, so I don't know. You are the presenter now.
Yes.
So
So
make presenter.
share again. It's not work.
Presentation rights, and then I make you presenter. Okay. You need to share your screen. You need to.
I should click on the share screen.
Okay, let's do one thing. You go. You can see your screen, right? I can't. I don't know if others can see the screen, but let's just go ahead. Let's listen to what you have to say because I know what the material, what it is, what the case is. So you can go ahead.
Yes. Still not see, right?
Anh Liêm ơi, nếu mà được thì anh có thể nhờ một bạn khác ở trong nhóm share screen được không ạ? Nếu mà anh không
Được,
tìm thấy
được.
share ạ.
Nhờ Khánh được.
Chị Nguyệt Khánh đúng không ạ?
Đúng rồi.
Đây để em sẽ chị làm.
Khánh ready dùng cái. Sao cái bật screen share không có được ở đây?
Chị Khánh ơi, em vừa set chị làm presenter rồi đấy ạ. Chị share hộ em màn hình nhé. Thầy lại set lại anh Thông làm. Chị Nguyệt Khánh.
Nó báo nó bị lỗi gì đó, không rõ. Vẫn chỉ thấy màn hình của thầy.
Professor Basu.
Yes.
Mr. Liam cannot to share their
I made him the presenter. He's not the presenter.
Yes, so Miss Nguyệt Khánh, her teammate, will be as a presenter. I will make her as a presenter now.
I'm making you a presenter once again.
Yep.
Okay. Yeah, well, liquid Tran, 1 minute I can give you. 1 minute, yeah, 1 minute.
Linh cũng bị lỗi luôn. Khánh bị lỗi hả?
Okay, I made you the presenter, Khan.
Nó mình có nhìn thấy màn hình của em không ạ? Em vẫn share được mà nhỉ?
I made you the presenter. Yes, I can see the screen now. I mean, it's started. Yeah, I can see the screen. Go ahead.
Yes.
I can thank you. I can see the screen.
Khánh để full screen Khánh ơi. So, good evening. I'm sorry for some technical problems. So, on behalf of the group, I would like to present the assignment of the group on financial risk management. So, the agenda is we have different topics on the fund risk management and other risk analysis also in the conclusion of the group. Next. This is the background of the group, the fund, and everyone already aware. So this is the US fund with the 5 billion raising fund. So they have arbitrage treasury with a different investment product on the buying the yield corporate bond, trading between US government bond and the emerging market. And also they are playing also 30% of the capital on the equity market treasury. So this is the mixed investment product we can see from this fund. Next one. You can see through the analysis of the fund, we have the main market risk, like the team is mentioned. First is the linked to interest risk through the bond and to the U.S. government bond. As you can see that the interest rate can happen within the U.S. country, also the investment with the emerging market between among across the border. And secondly, also linked to the equity risk, because 30% of the capital is expected to use in the equity market. So, there's some volatility of the stock price, and it can create equity risk also. Furthermore, if we look at the cross-border management, also for further trading, we have also currency risk. And also we have a default risk in case of the high yield corporate bond, and there will be high risk of default. So this is the key risk that happen when the fund handle the a kind of mixed product investment. Like we already see this. Next, please. So based on the risk analysis, and we can see that there are three main scenarios that we see that is losing a substantial amount of the capital. The first thing is linked to the rising of the interest rates. It can be implied the bond have the higher volatility and also more sensitive to change. So if we have the issue and the return of the short portion of the bond, government bond may not be sufficient to cover the loss. The second one is linked to the bond issuer go bankruptcy. So you can see, we can see at the two level. The first level linked to enterprise level that through the high yield corporate bond. So if the bond issuer go bankruptcy and therefore it become very insolvent, and that it can be low value and very big risk for the fund. And also the fund also invest cross-border to the emerging markets. So there's also the country risk default. So in the situation that, the government, they face the very huge sovereignty debt, and they lose on the obligation to pay for the bond issuer, bondholder. So this, it can happen like, some country before, like Argentina, like Russia, like Lebanon. So this is some, it's one of the critical risk we feel that most severe scenario. And of course, also we have some low liquidity in emerging market because when we choose to make the high return, high risk through investment in the new market, it brings a lot of risk. So when we have less investor involved, so liquidity is lower than the normal market. But in the crisis scenario, when many investors, they try to sell at the same time, so the market will be very difficult to liquid. So this is the three substantial losing amount of capital, and we can see that it's a combination of different scenario. But bond issuer go bankruptcy is still among one of the most severe scenario on that. Yes. Next, please. So based on the analysis, we have different framework how the fund will monitor and manage the risk. So in terms of the framework of management of risk, we have 5 frames. First is to define a clear business investment strategy. For example, like the fund work on arbitrage, strategy, what kind of investment strategy they want to launch, like the kind of portfolio management, or they mix the product investment or else. And also they have to have a different, risk appetite. They have to have ability to accept some risks, because when you make some, investment, you have to accept some certain level of risk. So what kind of limit the fund would like to do, there should be some ability to make the analysis on that. And in the other way, also linked to depend also on the complexity of the business operation, right? In the country in US or cross-border management, and how the fund also can be measured and manage the risk. So in order to reach the framework of the risk management, and then there should be a different tool to measure the risk through the interest rate. We can see the duration of the bond, depend on the sensitivity, become the value at risk. For example, like the full risk, also we can, based on the credit rating of some, association, in order to define the right level of credit when the fund decide to make a trading with some corporate bond also, or through cross-border management. Based on the methodology of risk control, we can make some define on setting the risk limit balancing the risk and return, because there's one way the question between how we make a good balance on that, what kind of scenario we can do on that, and how to make the good management on the cost also and the leverage, because sometimes we need to use some leverage in order to make some trading, some investment on some bond or some cost border management, and how to monitor the daily market movement, because when the fund is decided to make some trading on the stock market, so the keep updating the stock market situation is so important to see the movement and to take the right decision on that. And of course, afterward, it to build a good reporting and handling evaluation. And through that, we can have different solutions on the risk product management through interest rate swap, currency swap between different currency, depend on the portfolio of the product that the fund decide to invest in different country. The bond forward also, we can use the pool of put option by Blackstone pricing model to calculate the fair price of the call of put option in order to make a good decision on that. And also they can use some CDS contract, for some scenario that we are facing some default on that. So this is overall the key framework and also the tool and methodology to use, and it depends on each context, each kind of portfolio, each kind of context, and the investment environment, the trading that the fund need to combine different methodology, product, and how to make it measure will be depend on the time frame and also different scenario in order to apply this. Next thing. In addition, also when we talk about market risk, so when we the fund decide to make some investment, some trading activity, we need to take into account a kind of total risk. It's not only about different credit risk or default risk, but it's also linked to the macro environment. When the fund decide to invest inside the country or cross-border emerging market, we can see here like the internal corporate policy. So if the company that the fund decide to invest in, they change the policy, and then it can be totally changed on the governance, on the treasury that make the evolution of the bond less attractive or more attractive. It depends also on the environment risk, economic risk, and also there's some change from the government. They can make some change on the policy, legal risk, political risk, can create the rating of the country different. The risk to invest there is different, especially in the emerging market when the policy is not really stable. The legal framework is still updated. So that is something that the fund need to take into account. And also there's some force majeure issue like risk of the weather, the disaster, geographical risk, and so like the situation we are facing now. So when they make some decision, they need to take into account the total risk, including the other risks that we are talking about here. Next thing. So in order to mitigate risk, there are different solutions. First, linked to the technical solution, a fund they need to buy. So they can buy some insurance, right? When they're facing some risks in order to secure some investment they done, or the fund can decide some different portfolio, right? It can be different bond from different company or different country linked to corporate bond in order to diversify the investment portfolio. And this all depend on how what is the target of investment and how the the trading activity and the risk and return balance I mentioned before to decide that. And of course, in case the situation is out of control and the fund need to make some stop and loss, to timely information, how to stop and cut off the loss is important. Sometimes you have to quit some investment in order to regain, to reduce the loss if we can. And of course, to mitigate the risk, also the fund also need to base on the rating agency of the Moody or S&P, where they make some macro analysis and they take into account all the economic environment, inflation, consumption, the trend of industry, and the reason also, in order to make some credit rating level per country. And that is a good reference for any fund to take into account in order to mitigate the risk. So in summary, you can see the solution to mitigate the risk is all depend on the technical, expertise of a fund, and also you take into account the macro environment and also some very aggressive or quick decision making from the investor. So this is the summary of all the solutions we propose in order to mitigate the risk. So thank you for that. Do you have any question?
Okay, thank you. Good presentation, and I would say just elaborate a little more when you are submitting the report. Okay.
Yeah.
Who's next?
Thank you very much.
Okay, I have made you the presenter. Tran, I've made you the presenter.
Chị Trúc ơi, thầy đã set cho chị làm presenter rồi đấy ạ.
Chị Linh ơi, cho em hỏi cái dấu xe nằm ở đâu rồi chị?
Okay,
Nó
go
sẽ
ahead.
ở,
I've made you the presenter.
nó sẽ nằm ở bên cạnh cái nút mà mở camera ấy chị. Mình sẽ thấy có 3 cái nút là cái mic này, loa này và cái xe webcam. Thì bên cạnh cái xe webcam sẽ là cái nút là share screen. Chị thấy chưa ạ?
Tại vì bạn Trúc sẽ share screen rồi mình nói. Trúc ơi, em thấy chưa? Trúc vẫn chưa thấy á chị.
Vì đang có 2 account đều là Nguyễn Ngọc Trúc Trần thì là account nào là account? Có một cái account là mobile và một cái account là của laptop đúng không ạ? Để em share lại với cái account của laptop nhé. Chị Trúc check lại giúp em đã được chưa ạ? Ok ạ.
Good evening, Professor and everyone. So I will be the presenter on behalf of the group 5. So this case study is talking about the US fund with the arbitrage strategy, which will get the profits from taking advantage of price differences in different markets for the same asset. This fund are also using the leverage to maximize the return for some cases. So for summarize, they are doing 3 main of the activities. The first activities they're doing is about buying US high-yield corporate bond and shorting US government bonds. And the second activity is trading spread between US government bond and the emerging markets. The last one is they will spend around 30% of the portfolio to invest in the capital market, in the equity market. So the question is, what is the main market risk factor for this fund? We find out totally there's a 5 main market risk regarding to this fund. So the first one is regarding to the interest rate. When the fund using leverage, they will suffer from the loan interest when the bank rate increase, which will directly affect to the interest cost and also affect it to the return of the fund. And regarding to the default risk, for the default risk, when the fund invest in bonds, for example, invest in the emerging markets, where the politics are not stable, so the fund manager needs to pay attention to the default risk of these countries when they are much higher risk than investing in a developed market. Talking about the currency risk, also in the same situation above, the fund manager also need to keep his eyes closely to the currency movement, which is related to the currency risk when the exchange rate is fluctuating. About the equity risk, you know that this fund is using around 30% of the portfolio to investing in the equity market. So the volatility of the equity markets also becomes the main market risk here. And for the last main risk is regarding to the commodity movement risk, because this fund is invest in the equity fund. So if any of the single stock in this equity fund is invest in the commodity, they will also face with the risk when the commodity price is fluctuated. Talking about the secondary risk could also become the important. So we find that the volatility of the underlying assets is kind of the secondary risk. As mentioned, the main strategy of this fund is arbitrage. So when the underlying assets is volatile, this fund may face to a big loss. And another secondary risk is about political risk. You also know that there's always some potential risk when investing in developing countries than developed countries, such as the unstable political, unstable regulations and law, unstable banking system regulation, which may result in loss to the fund, or the fund will get in trouble to get the money back to their home country after investing. So the next question is, which scenarios will bring the serious loss to the fund? Uh, we we find that there is two scenarios will bring the big loss to the fund. So the first one is regarding to the interest rate risk. There's a negative correlation between the interest rate and bond price. So when the interest rate decrease, the bond price will increase. So it means that there will be a big loss for shorting US government bond scenarios, because when the fund is at a shorting position, uh, it will gain it will get the gain and gain only when the underlying access price is decreasing. And the second scenario we think that it will bring the big loss to the fund is regarding to the default risk, which is applied for the coverage bond and equity investment, especially when the fund is investing in high yield bond, which contains high risk with a low credit rating. So when the bond issuer goes bankrupt, and in the case of no collaterals, the fund will bear a big loss from the investment. So what is the elements should the new risk management framework covers? We also have the same idea with other group. There's totally five components of risk management framework, like risk identification, risk measurement, risk mitigation, risk reporting and monitoring, and the last one is the risk governance. So how can we measure and manage these risks? There's a few methods to measure the risk, such as the sensitivity analysis, VAR default risk, and to monitor and control these risks. It depends on which risk they are. So if we are talking about a currency risk, the methodology is based on the market factors, such as the movement of the strong currency baskets like USD, GPY, Euro currency. Measure and forecast the portfolio value with the current, and the portfolio manager, they also need to forecast for the currency movement in the future. If this is a credit risk or credit default, the portfolio manager, they need to revalue the current portfolio valuation with the updated collaterals and cash flow of the company they are investing in. And the PM, the portfolio manager, they also need to meet directly with the company they're investing in to make sure that their strategy is stable and consistent with the business growth. And for the last one, if this is regarding to the interest rate risk, it will based on the inflation base in US and in the investing countries. If any signal of the inflation rising, then the risk may occur to equity investment. because when the inflation rising, the investor will prefer to move money from the risky investment to the safe investment channels in a high inflation period. So then the portfolio name manager, they need to reevaluate the portfolio valuation again. And what kind of the products can be used and to manage this kind of the risk? So when you are trading in the OTC market, there is a counterparty risk need to be aware of, especially the counterparty risk of the for the bond derivative. So you can reduce this risk by requesting the counterparty to make a deposit for the transactions. And if to manage the default risk, you can use the CDS to transfer the credit exposure from other parties, such as the bank. And to hedge for the currency swap, currency risk, you can use the currency swap to hedging in terms of the leverage case. And what's the other risk we can find from this case study? As mentioned, investing in emerging markets contain a lot of potential risks, such as risk of politics, risk of liquidity, risk of regulation, policy, and you may not able to get the money back after a few years of investing. So how could be this kind of risk to be mitigated? Uh, Actually, we should not put all the eggs into one basket. Therefore, diversifying the portfolio into variety markets, variety countries is a good choice to mitigate the risk. Besides that, the fund manager also should monitor, they also watching the market movement closely for both macro and micro factors. And they also need to proactive to meeting with the company they're investing in, even they're investing in equity or in the corporate bond, to understand more about their governance. And then the portfolio manager will have the proper and the prompt action in the negative situation or in the bear market to reduce the loss and keep the fund outperform. So that's all for our presentation. Thank you for your listening.
Thank you. Good. I think some of the things you said is very interesting. I look forward to reading your report in detail.
Thank
Okay,
you.
next is Chen, right? Let me make Chen the presenter. Yeah, I made you the presenter. You can go now, Chen.
Hello? Can you hear me?
Yeah, I can hear you.
Okay, so I'm gonna start my presentation. So, hello everyone.
Yeah, I can.
Our group 6. Yeah.
Okay, you can start. I can see your thing on this
Hello?
machine and on this one. Or it'll come up on the other one. You can start. I can see your slides.
Okay. You can see my slides, right? Can you? Okay. Can I start?
Yes, we can see your slides. You can start. Oh, we could. You just switched it off. Yeah, start.
So, we considered the market risk exposure of the fund, and then we see that there is volatility risk with the high with the 30% of the capital in equity market, so it's going to have a bigger volatility risk, and because of the high yield bond is correlated with the stock market performance. So it also has a high volatility risk. And there's also credit risk. So it's also like a default risk. And there's sovereign risk, interest rate risk. If the interest rate is variable, it can decrease or increase against funds interest. There's leverage risk because the fund is using leverage to make profits. So there may be a more risk while they're like making their strategies. And there's also liquidity risk. So the arbitrage strategies need liquidity to have cash available to act quickly. So we identify that the main risk is the volatility risk because it is like 30% of the capital, and as spoken that the bond is also corporate bond is also highly correlated with the equity market. So we define this as our main risk. And our secondary effects are credit risk, also fraud risk. So while if the economy goes down, like when there's an economic depression, besides the price of stock market and bonds will fall, the chance of corporate not paying back the payment will also increase. So so we see that the risk that may make the fund lose substantial amounts of capital is when the counterparty cannot pay back the bonds or they delay the payment. And then if there's a scenario B, if there's a market crash or a financial crisis, and scenario C, losses due to leverage and misassessment of market evaluation, and if there's no hedging of risk. So consider how the market risk could be managed, and then like every other group has presented, like it can be managed by identifying and assessing the companies or the market situation, and by monitoring, controlling them, and finally mitigate them. And over here, the role of risk management, we see it as risk-aware mindset and structures, lead growth, risk and return, new market opportunities, and risk mitigation. And the new risk management framework should cover like the risk we mentioned above: market risk, credit risk, sovereign risk, interest rate risk, leverage risk, equity risk, hedging risk, liquidity risk, and all the other risks that can be identified. Following slides, I will hand over to my teammate, Matthias, to present. Matthias, can you open your mic?
Yeah, can you hear me?
Yeah, I can hear you.
So now, how will risk be measured? So we need to be aware on all the risks that can be identified. To measure the risk, we can do some studies like country risk analysis, market risk analysis. We can do some forecasts, and we can compute the credit quality and do some ratings of the bonds by mitigation matrix. It determines the chance on the company defaulting or rather not paying back our investment. And then what methodologies could be used to limit, monitor, and control the risk. We can do some standardization of loan review to examine the credit status of borrowers or bonds according to certain procedures and indicators to avoid possible credit risk. We can also for decentralization of loan objects, which is a traditional methods of managing credit risk. And we can use asset securitization to form an asset pool of bonds or loans with credit risk and sell them to a financial institution or investor. From an investor's point of view, securities resulting from this combination of assets are attractive because credit risk is reduced by investing in a combination of multiple loans or bonds. Next slide, please. So what kind of products can be used and how manage the risk? So the products that can be used to mitigate risk are derivatives like options, of put and call options. You can use also combination of put and call option. We can also use swaps, which is a kind of derivative, and then we can also use insurances. Sorry. We to manage the risk, we can diversify the portfolio. Indeed, in a well-diversified portfolio, losses in one sector tend to be offset by gains in another sector. So we need to try to diversify companies and government bonds, to diversify countries and currencies portfolio. We have to balance risk and return. Indeed, a portfolio composed entirely of speculative and growth-oriented stocks has the potential for large gains as well as large losses. So a portfolio focused on federal government bonds would have low risk, low returns. But if the returns are so low that they don't even keep up with inflation, the purchasing power of your saving will gradually diminish. We can just to manage risk, avoid certain risks when one have already identified some risk and they are too important. We can avoid them. We can hedge certain risks by insurances to transfer them like operational risk to an insurance company. We can hedge market risk by derivatives. So like with a put and call option combination. So for instance, we can use some protective put option or protective call option to mitigate some market risks. We can also use swap derivatives like currency swap to avoid currency risk, like CDS to mitigate credit risk or interest rate swap too. And we can take advantage of market volatility. It's another way to use derivatives. So the natural fluctuation in market price can generate opportunities. And we can use, for example, if there is a market with high volatility, we can use a Stringle, which is a combination of call and put options. That's it for our presentation.
So that's
Okay,
it.
thank
you,
you.
everybody.
Just a quick thing that other risks you should highlight a little more in your presentation, in your report. Okay, I'm going to the next person. So let me make you the presenter. Yeah, I made you the presenter. The next person, Gwen.
Chị Dung ơi, thầy đã set cho chị làm presenter rồi đấy ạ. Chị đã thấy nút share screen chưa ạ? Chị Dung ơi.
Yeah, I've already made her the presenter. So
Em đang thấy chị set thầy set cho chị là presenter ở trên laptop đấy, tại vì một cái chị đang vào bằng 2 account thì một account là điện thoại đúng không ạ? Thì account điện thoại là thầy đã không set là presenter rồi.
okay, we have one more group after this, right?
Professor.
Yeah.
We have only one group, 7. So she sent the PowerPoint for me, and I will help her to share.
Okay.
Yeah. Wait for a minute.
Okay, sure.
Hello. Hello. Sorry to keep you waiting for me. Can you hear me?
Yes, we can hear you now.
Yeah. So sorry, due to technical issue, I cannot click on the share function. So sorry to keep you wait for me. It's now already over 10 o'clock. I'm from
No
group
problem.
7.
You've got your screen. You can present now. We can see your screen.
Yes, I see. Thanks. So because all the group already present very clearly and detailed on the necessary point, and I just go very quickly because now already quite late and already everybody may skip me right now. Regarding I will present first about the risk management framework, and then I will come in the detail later on. So regarding risk management framework, there are some steps of risk management framework like risk identification, risk management, risk mitigation, and assessment, and then risk monitoring and reporting. The last one is risk governance. The detail, I think I should not necessary to go in detail. The second one, I would like to address the risk instrument management. We have several risk instrument management like option like swap, interest rate swap, currency cross currency swap, insurance, CDS, cross derivative swap, future and forward. How to measure the risk? Like there are several ways to measure risk. Like for interest rate risk, for bond we do rate sensitivity analysis, value at risk, equity risk. We also have instrument like value at risk, sensitivity. For currency risk, we have a value at risk, and for default, we have a credit rating assessment. The next point is about risk control methodology. We also have to set some methodologies for risk control, like setting the risk limits clearly, balancing risk return, controlling investment cost and leverage, monitoring the daily market movement, building a process of reporting, handling violation. So regarding the detail of the fund management, there are some potential risks related to their activities, such as for buying US high yield corporate bond. High yield is mean high risk. High risk has maintained the more concern is the default risk. For default risk, that's the default risk is more the more concern risk we care. Next is interest rate risk. The same with other bond. When price go up, interest rate go down. When interest rate go up, price go down. It's similar to other bond. And another point is FX risk, because they buy government bond from emerging market. I mean, they involve multi-currency investment, and it's also involved in FX currency translation risk, FX currency depreciation risk. And when they stock in the U.S. government bonds, when they stock U.S. government bond, they are no concern because government cannot rare government can fail. But they are also concerned in when they invest in emerging market. They also have concern of the sovereign risk, and the credit default risk of that country. There is a country risk. Yeah, emerging country normally risk rating where country risk rating very low, and then they invest in also in equity market treasury with 30% of the fund. The more concern is the currency risk. Like I mentioned before, is translation currency risk. It is the more concern. For interest rate risk also was not significant because equity. For bond interest rate risk is more on point need to assess. For equity, it's just the volatility of stock market movement. And for when stocking U.S. government bond, they also involved in bonds the same interest rate risk is more concern. So in general, that is several and this side also involved in liquidity risk. Liquidity risk here is the unmatching or the liquid of capital, because the unmatched between cash inflow and outflow of investment. And another point need to address is the credit risk. Credit risk here is also sometimes is also a default risk of emerging market, default risk of the bond issuer, because high corporate bond, high yield corporate bond, it means low rating. And also in the tank credit risk involved in settlement risk, country counterparty risk, and investing risk. They also other operation need to address like fraud risk, cyber security risk, and third party risk. So in general, there are several overview of the risk the bond have to involve like that. And regarding the management framework and the instrument management, and also risk measurement and control, I already mentioned. And because time limited, and I will make some more improvement on my report and send to you later on 25. That's all for me. Thank you for your listening. I don't bother you so much, so it's quite too late now.
No, it's okay. Thank you very much. It's quite good. I mean, the
Yeah,
points you made were very interesting and relevant. And I definitely can see some more work that you've done, and I'll look forward to reading the report that you guys will
yeah,
have to
yeah. I
submit.
will do a
Okay.
report improvement and send you soon
Yeah.
later on.
Sure.
Yes. Thank
Yeah.
you so much
Okay.
for listening and
Thank
sorry,
you.
so sorry
Thank
for
you.
you waiting. Yeah,
No,
so
no
late.
problem. Don't
Yes.
worry. These things happen. Don't worry about that. So I think that's the
Yeah.
end of it. Good. So thank you all very much. I know it's quite late. It's like close to 10:30, so I don't want to, keep you all too much. What I've done is I've also put out my email out there for you all. So, do feel free to send me emails if you have any questions now or before the exam. And I'm sure before the exam you may have a few questions. All the best. Okay. Thank
Yeah,
you.
yeah, yeah. Yeah, yeah. Thank you so much. Thank you.
Thank you. Thank you.
Yes, bye bye.
Thank you.
Yes, bye bye. Yeah.
Bye. Good night.
Bye. Good night.